All right. Well, welcome once again to Astronomy Daily Live. Nice to see everybody here. This is the Obs-Session for January 27th, 20. Yeah, I can do that. 2019. So hope everybody's doing well today. Hope everybody did good. So come on in, everybody. Welcome, welcome, welcome. Yeah. So we're out here again. I'm out here, that is, and you know, collectively we are here out out here again under a beautiful, beautiful, dark southeastern Arizona sky, and no high clouds yet, but I think they might be moving in. I'm not exactly sure. So, welcome everybody. So, I've had a pretty successful pre-observing session. For the past several observing sessions, I've noticed that the images of the stars have been these streaks, maybe 4 or 5 pixels long, and I've been scratching my head and scratching my head trying to figure out what is going on with that, right? What's going on with that? And I thought for a little while, well, maybe it's the mount, right? You know, the tracking in this mount isn't great. So I mean, I've got drift, but what I'm seeing is little tiny motions, right? Even a 1 second exposure, right? I was getting a streak, right? So in my head, I'm thinking, okay, it's got, you know, poor overall tracking, right? I mean, you know, there's a drift, right? But it's also doing this, right? So, I'm like, okay. So yesterday I rebalanced the telescope, so it's pretty nice and balanced now. I did have to move it a little bit. I actually, you know, and this is something that you want to avoid. But I had the entire OTA and camera balancing on one finger, right? I was trying to get it really, really, really well balanced. Now, I don't recommend that you do that unless you're a crazy astronomer like me. So, so it so I know that it's balanced. Last night's session was cut a little bit short with some high, thin clouds that just decided to plant themselves right over southeastern Arizona. It was clear. It was clear everywhere else, right? Except for right where I line up very, very precisely um, in order for um, the star images to be nice round points of light and not little streaks. So um, this morning I actually took a a little laser pointer and I pointed that laser pointer at an index card on my wall, right? And about 50 feet away, I pointed the telescope at that telescope or at that laser spot, and I defocused the camera and I defocused the telescope, collimated the telescope. I lined up everything as you know precisely as I possibly could. Crossed my fingers. See, here's the crossed fingers there, right there. And waited until tonight. So I got out here, took my kind of was like, well, clouds are gonna roll in. Should I do this? It's like, yes, I'm gonna do it. Because that's one of the hallmarks of doing astronomy too, is that you got to be really stubborn about things, and it's like, damn it, I'm just gonna do this, right? So I took my cows right after sunset, like I have been doing for quite a while now, and by that time it was just starting to get dark. Right, I could see Capella, I could see Betelgeuse, I could see Rigel, I could see a few stars. So it's like, you know what? I'm going to do my alignment, and then I'm going to um, actually get onto the sky. I actually chose M37, which is one of my favorite open um, clusters of all times. And it's like, I'm going to take some images, right? And take some images um, and run them into the house, into my office. Take a good hard look at them. Make sure that they're, well, see whether they're still streaks or whether they're nice round things. And I'm happy to report, happy and relieved to report that. And for some reason, I'm not seeing any chat. I don't know if there's any chatting going on, but I'm going to. Yeah, okay. Sorry about that. It's buffering, huh? Buffering. And audio is bad. Yeah, that's, well, we're all going to have to put up with that. But I noticed that Bobby is in the chat and Desiree is in the chat. So nice to see you for sort of as well as you possibly can. But anyway, bottom line is that um, it was a collimation problem, right? I didn't have the optics lined up exactly right. And so when I did that, it looks like everything is looking really, really good, and therefore full steam ahead, right? And now what I'm doing is I'm basically just sort of waiting for astronomical twilight to end. Um, there are three sort of phases of twilight, right? Um, Once sunset occurs, we're in what's called civil twilight. And civil twilight goes from when the sun is right at the horizon, 0 degrees um, 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 altitude, to when the sun is 6 degrees below the horizon, right? At 6 degrees, we go into nautical twilight latitude. It takes about an hour and a half or so. So I'm really, really, really close to getting into astronomy, or into darkness. So what I've been doing actually is just pointing to my first target, and that's about it. So I'm going to switch you over to the screen like I have been doing this past few nights. Hey there, Justin T. Justin T is in the room, and yeah. Well, sorry about the buffering and the audio. That's nothing much that I can do about that. But okay, so I'm gonna move you over here. You can view the screen, view the same screen that I'm viewing. It is on the chart here. There's sort of a 7 o'clock thing here, and I'm trying to remember where I saw that before. Um, I will find it rapidly. The star that I'm going after is this dude right there. Um, but yeah, I'm trying to remember exactly where that was. Um, I think it's that. I'm gonna move the stars up a little bit and see if I can. I need to confirm. Yeah, okay. All right, so I know exactly where I am now. So what I need to do is I need to move these stars to the right. And in fact, I'm going to move these. Well, yeah, I'm just going to move them to the right because what I should bump into pretty quickly here is a couple of other bright stars, and those two bright stars are right next to my target. And my target is actually a magnitude 8.24 star, really, really bright. And it's got a little friend next to him too. So I'm just going to scooch these over, and I should see one of those two bright stars uh, moving in here momentarily from the left. So I'm still not quite dark yet, so I'm not going to really necessarily be collecting any data yet. Yeah, it should be, yeah, okay, there's one of them at least. Okay, there's one of them. And I'd like to be able to see the other one, but I might not be able to. If I can't, I'm going to keep moving this little guy here to the right. And I'm going to, hey there, ERRT radio. Buffering is really bad. Yeah, all right. Well, sorry. Sorry about that. That's life, I guess. Okay, so there's my other guy. Now let's I don't think that this is my target. Oh, it is. It is. You see this little guy up here? Okay, so what I'm going to do is I'm going to move him to the middle. Slowly. So, yeah, sorry about the buffering and all that. Not much I can do about it, unfortunately. Okay, and then as soon as I move him to the left, or to the right a little bit more, I'm going to move it down. Okay, so here we go. We're going to move down. Down we go. Theoretically, put my glove back on. Gloves and smartphones don't mix. They need that capacitance. Should see a couple little friends up here too. So very good, very good. Actually, yeah, okay. Excellent. So that's a magnitude 8 point, I think it's 8.24 if I remember right. We'll confirm that. I'm going to scooch this up a little tiny bit more because I want to see those 3 stars. Okay. All right, I think we're good there. I'm going to stop the motion. As you can see, the tracking is kind of funky, but I'm slowly learning how to deal with all of that. And it's really amazing. I mean, these are 1-second exposures, and some of these fainter stars here are like 15th magnitude stars. So doing pretty good. Doing pretty good. The focus is great. I've already done the sky alignment. I've already done the focus. So I am ready to rock and roll. I want to try to catch this before I get these high clouds moving in. Okay, so now we should be good. Let's see if it locks in. If it locks in, then I'm going to go into data acquisition mode. Yeah, it looks like we're good there. Okay. So I'm going to go into data acquisition mode here. So I'm going to zoom you out. And again, sorry for, the buffering problems, but that is life out in the middle of nowhere. Okay, so I can put my chart away. I can abort that. And this guy is going to be 25120. Twilight. So I will be right back in just like 20 seconds, 30 seconds. Yeah, we are good. We are good. All right. Well, so now we just sit, and I have to sit here and make sure that I keep my target in the field of view. And I like to keep a couple of these stars also in the field of view. So as you can see, it's slowly drifting up this way, but I've got a star up here, star here. I've got this nice binary here, and thinking that, okay, I'm probably going to scooch him down and to the right a little bit. So very good, very good. I cannot tell you how happy and relieved I am that these star images, yeah, I like to confirm that I'm actually saving the data, so yes, I am. I cannot tell you how happy and relieved I am that these star images are once round again. So the collimation was definitely off, right? But it wasn't, well, any bad collimation is bad collimation. And so, made the correction, and bam, it's I've got beautiful, beautiful, beautiful round stars. I've got good focus. I'm looking up in the sky, looking at the twinkling stars, right? A measure of good seeing is whether the star, or how much the stars are twinkling. And the stars really aren't twinkling too terribly. I mean, it could be a lot worse. I'm looking at Sirius, which is about, I don't know, maybe 15 degrees above the horizon right now. And so I'm looking through a lot of air, right? A lot of air there. It's twinkling pretty decently. But then I'm looking above, right? I'm looking about 30 degrees above the horizon to the constellation Orion. And I'm looking at Rigel, and I'm looking at Betelgeuse, and those guys are hardly twinkling at all. So I think the seeing is really, really good. I will show you my conditions. It's 32 points. I'm going to move those stars down a little bit. It's drifting a little bit too high. So on the next exposure, all the star images should go down. The download time here is about 14.2 seconds or so on average. It varies a little bit. I'm going to maybe scooch those down a little bit more. I'm going to check this next image out, and then we'll go from there. So, yeah, all right. Well, we are doing good so far. Yeah, that moved down sort of an adequate amount. Yay. All right, well, cool. Trying to think about what to chit chat about here. I've been sort of focusing on this stuff primarily, so haven't really been following anything else. I've been really fretting about these star images being weird, And but now I can sort of start worrying about other things. So that's nice. That's nice. Yeah, so that'll slowly drift back up. So all right, well, cool. Um, let's see. Very very nice dark night. Definitely see the Milky Way going directly overhead, just to the. It sort of goes through Cassiopeia, which is in my sort of northwest, north, yeah, northwest right now, and it's sort of going almost directly overhead. I've got the Pleiades right at the zenith right now, and then the Milky Way goes through the constellation Perseus and Auriga, and to the east of Orion, and sort of down east of Canis Major and Sirius. Now, when we're looking at the Milky Way this way, we're actually looking out, right? Um, Sort of 180 degrees from the center of the galaxy, right? So we're looking out, and that's why it's not quite as bright as when we're looking towards like Sagittarius, right? When we're looking towards Sagittarius, not only are we looking towards sort of an intrinsically brighter area of the galaxy, but we're also looking through more stuff, right? We're about, at least we think, we're about 2/3 of the way out from the center of the galaxy. So when we look towards the center of the galaxy, we're looking through about 2/3 of all this stuff. And when we look 180 degrees uh, opposite that, we're looking through about one third of the galaxy. So there's just less stuff, and it's slightly less intrinsically bright as well. So I move these stars down a little bit. Let's make sure that it actually moved down. Focus looks really good. No complaints. Yeah, okay, so I think I'm going to move it to the right a little bit as well. Slowly getting the hang of all of this. I've only, been doing this kind of stuff for, you know, 30 years. You'd think I'd be able to get a hang of it. It takes time. It's a learning curve for sure. But yeah, it's a beautiful night. And it looks like at least I'm going to be able to get this first data set covered. So yeah, this is part of a program that I'm working on to actually characterize this telescope system, right? What I mean, I have two basic goals. One is to do my own research because I am a research astronomer and I want to be able to collect, data for, the kind of research that that I might want to do. I also realize that my location and my conditions here in southeastern Arizona are very, very, very much desired, right? Um, by people all over the world, right? They want to have these kinds of conditions that I'm sitting under right now, right? And they don't, right? They're sitting in clouds. They're sitting in, you know, uh, not so ideal conditions. But I'm located in a very, very prime spot when it comes to collecting all the astronomical data that is needed, to do research. So I think that that is a desired thing, and so one of the other things that I'm doing is I am selling telescope time. So you can talk to me about that, and I can get you all set up. I'm going to scooch that up and to the right again. So there's all kinds of research that can be done by doing this kind of um, acquisition of data, right? Uh, what sort of the two fundamental measurements that can be made with CCD data is position and brightness. And so I can look at this and very, very, very accurately measure the position of this target, say, in the sky, right? Because I know, well, yeah, I basically know where the telescope is pointing, and I can also calculate exactly where that star is um, on the CCD chip. And if I know that, I can measure the right ascension and declination of that star to some level of accuracy. That's drifting down a little bit, so I'm going to scooch him up a little bit again, just like that. So this one will continue to go down, but the next one should be scooched up. Should be scooched up a little bit. And the other thing I can do is I can measure the brightness of these stars. And, it doesn't have to be a star, right? It can be any astronomical object, right? It can be a galaxy. It can be a nebula. It can be a cluster of stars. It can be a binary star. It can be anything, right? And so what I'm doing with this data is I am collecting it in order to measure the positions and brightnesses of these stars and then compare my measurements to those of sort of a known, trusted catalog. And in my case, I'm using Gaia, right? So the Gaia spacecraft is actually out in space right now, collecting more data for their third data release. But earlier, well, last what was it? Last June? Was it last June? April or June? I forget exactly. Gaia released their second data release, and you may have heard about this. I mean, I've talked about it too. Something like 1.8 billion stars, whole bunch of galaxies, 14,000 asteroids, and they measure position, brightness, color, motion, distance, just all kinds of parameters, right? So, and this catalog is supposedly a trustworthy catalog, right? So when they measure the brightness of that star, right? And this is actually, we can look at the list here, right? Gaia says that it's magnitude 8.24, okay? So when I measure the brightness of that star. Well, how close is my measurement to what Gaia says, right? Am I getting relatively close, or am I way, way, way off? And if I'm way off, well, why am I way off, right? But what I'm seeing um, right now with sort of a limited sample of stars. I've looked at a few clusters of stars, and I've looked at a few single stars like this, and I'm getting accuracies of 10, 20, 30 millimagnitudes, right? So just to give you a perspective there, right? So the magnitude scale is a brightness scale that astronomers use, and it's sort of a weird upside down backwards thing, in that the brighter the star, the smaller the number, right? And those numbers can actually go negative as well, right? So Vega is um, um, our 0 point star, right? So Vega has a magnitude of 0, and then every difference of 1 magnitude, right? So a 1 magnitude change is actually a brightness change of a factor of 2.5, right? So a first magnitude star is 2.5 times fainter than a 0th magnitude star, and a second magnitude star is 2.5 times fainter than a first magnitude star, right? So it's a logarithmic thing. It's an exponential thing. Um, uh, so right. So the difference between 1 magnitude is a factor of 2.5 in terms of brightness. Okay. So what I'm seeing in terms of me comparing my brightness measurement to that of Gaia, I'm seeing 10 or 20 or 30 millimagnitudes, right? So 0.01 magnitude difference, which is really, really, really nice. I'm really, really pleased with that. But so I mean, you would think that I'd sort of be satisfied with that, right? Well, I'm not, because I'm extremely skeptical, right? And it's like, well, I've measured maybe 10 or 12 stars that way, right? Um, and so my confidence level is pretty good, but I want to raise my level of confidence. How confident am I that I can get, 10 millimagnitude accuracies? Well, right now I'm moderately confident because of the number of stars I've got, but I want to be more confident. I want to be as close to 100% confident as I possibly can. I'm going to scooch this guy up a little bit here after this next exposure. I don't want to be moving the telescope while it's taking its 1 second exposure, so I have to wait for it to be downloading, and then I give it a little scooch. So this next one won't show anything, but the next one, everything should be scooted up a little bit. So that is sort of the program at the moment, is to make measurements of as many of these stars as I can, and I can get 10 or 20 or 30 millimagnitude accuracy with stars brighter than about 11th magnitude right now. Okay, anything fainter than that, the accuracy starts to degrade. Once I get to like 13th magnitude or 15th magnitude, I'm up around 200 or 300 millimagnitudes, point 2, point 0.3 magnitude accuracy, which is still really, really good, right? But um, you know, not as great. Um, but it's sort of looking now that any stars that are 11th, maybe 12th magnitude or brighter, I can get into this, sub 100 millimagnitude range, which is really, really, really nice. Um, so that's one of the other things that I want to be able to advertise, right? Is that not only, right, is this a dark site that has quite a few clear nights, right? So your chances of actually getting your data are pretty good here. It's a very, very, very dark site. Um, which means you can see an 11th magnitude star easily, right, with a 1 or 2 second exposure, but also the accuracy, right? How well can I actually measure the brightness of these things is very, very nice as well. So, yeah, all kinds of possibilities open up when the accuracy is extremely high like that, or very, very high at least. So, yeah, one of the projects, right, is to actually measure the brightnesses of variable stars. Now, variable stars are stars that over time vary in brightness. And, you know, they can do this for a number of reasons. There's all kinds of different variable stars. Um, and one of the interesting things to do is to sit here, like we're doing now, and uh, watch these stars vary in brightness over the course of, you know, maybe minutes or hours, or maybe even days, right? It sort of depends on, the nature of the variable stars. One one of the variable star types that is really, really cool are called eclipsing binaries, and these are binary star systems, right? Where you have two stars. Um, One star is sort of the primary um, component, usually a little larger, usually a little bit bigger than the secondary component, which is usually a little smaller and a little fainter. And it just so happens that the secondary star from our line of sight actually passes in front of the primary star. And what that does is it makes the whole system dim over the course of a few hours, right? Um, and how it dims and how much it dims, how long it takes, all that kind of stuff, right? Um, can tell you lots and lots of things about this binary system. Now, you can't see the individual components, right? They're too close to one another. In fact, a lot of times, these binary stars are what are called contact binaries, right? These two stars are so close to one another that they actually touch. They're actually sharing a common atmosphere. So, imagine that, right? That's an amazing thing. Um, And, you know, a lot of stars are like that. So, including these um, eclipsing binary stars. So we're running right up to the end of our first target tonight. And what I'm going to do right after this is done is I'm going to take a walk over and look west. And I'm going to take a series of dark images now. Yeah. Okay, I'll be right back. Hold on. All right, the horizon's looking good. I don't see any high clouds yet, so we're doing pretty darn good there. Whew, it's starting to get cold though. Starting to feel it. Let's check the, oh yeah, here we go. So, whoop, let me, get rid of that. So 29.3 Fahrenheit and 42% relative humidity and going up, it says. So yeah, it's officially cold now, but it's early, and you know I'm not frantic or fanatical about just like going all night long and collecting as much data as I possibly can, and on and on and on. I'm gonna do, you know, three targets, maybe 3 or 4 targets. That'll give me a couple hours worth of time out here, and by then I'm gonna be feeling really cold. So I'm already feeling cold. So yeah. So I think what I want to do while I'm taking the darks is I want to start planning for my next target. Okay, so now I can get rid of this. Sorry. Okay. And I'm going to put another little mark here just so I know which ones I did tonight. And I guess what I'm going to do is I'm going to go on to my next target, right, which is almost an 11th magnitude star. Wow. Okay. So let's get it here. We're at 59.26. So 59.26 is about 0.25, right? So right in the middle. And we're at negative almost 0.8. So negative 0.8. Okay, I gotta go up a little bit. So let me 59.25 and zero point 0.8. It's probably this dude right there, which I know where that guy is. Haha. 0.8. Yeah, I think that's him. So he's really nearby. Put that right in the middle. And I can go over. Is that about? This is about 0.8, right? Here's 0.5, 6, 7, 8, 9. 0.9, 0.8 is somewhere around here. Yeah, that's pretty much right in the middle. So yeah, I think that's him right there. So I actually know where that is. It's right next to my other dude here. So cool. Okay. I'm going to be able to get him really easily. Just waiting for the darks to finish. The light sits on. It's created by the camera itself, right? The camera isn't at absolute zero, so there's always some electronic noise And so that's what this dark image is, right? I'm actually not um, taking an image of the stars. Um, the shutter is closed, but it still is doing a 1 second exposure. So yeah, it's just a measurement of like a pedestal that all the starlight actually sits on. But okay, so this is going to be done here. So I'm going to go back into, I'm going to turn autosave off. I'm going to go back into 3x3 binning. And I'm going to goose this thing up to 500 and we can start going. Autosave is off. Okay. So now what I need to do is I just need to, so I know that that's this guy, right? So, and our little friend should pop in here momentarily. There he is. That's him. This poor little guy right there. I know that you can't see that very well. Um, I'm going to go ahead and just get him in there. So I'm thinking maybe I want to knock off 2 at a time if I can. Let's see where this other one is. Ooh, he's there. Do I want to do that? I've got 2 target stars in the same field of view here. Be nice to knock off 2 of those at the same time, but that means keeping it pretty darn tight. Yeah, I'm gonna go for it. Scooch those over to the left a little bit. Okay, I like it. Make sure it's not drifting. Okay, I think we're good to go. So this is the one that I was going for, but this guy is also part of the program, right? This one is this one, and this one up here is this one. And then, I don't know if you can see these 2 faint guys here, but that's these 2 faint guys. So I've got both of these in the same field of view. I'm going to get them both. Yeah, I might as well. Kill 2 stars with 1 stone. How about that? So I'm going to go abort that. I'm going to go to 100 images here. 1 second exposure. 1x1 binning. And I guess what I'm going to do, I don't know this one. So I'm just going to go with this one, and then I can just rename it later. So this is 86688. 86688. 86688. I'm going to restart at 0. 0. Autosave on. And off we go. Hopefully they're still both in there. A nice big image again. Again, just... Alright, so I'm going to put him right in the middle, up and down, and I'm going to put him right in the middle, left and right, and then I'm going to check this. So that's really close to 5925, right? A little bit more than 5925. 5929. Oh, okay, well, here's one at positive 0.38, so that's definitely not it. But here's one at really, really close, right? Negative 0.71, negative 0.79. My guess is that that's probably what that dude is. let's see if there's any others that, because I mean, obviously it's right near this one. So are there any others that are near that one? Here's one at 0.47, but this is at 0.26, so no. Yeah, I'm pretty sure that that's probably it then. So 86688 and 45344. That's probably them. So I'm going to mark that one like that. And I'm going to mark that one like that. Just so I know, right? And he's magnitude 10.52, so he is a little bit brighter, right? It's hard to tell, of course, right? Kind of hard to tell because they're pretty close, right? I mean, what we see is the flux, right? Is the brightness, not necessarily the magnitude. And so the difference between a magnitude 10.96 and 10.52 is like what, 0.44 magnitudes, which is hardly anything at all in terms of differences in brightness. So yeah, they look about the same. It's amazing how well this thing is tracking. Amazing. To solve my collimation problem, probably what I'm going to do here is grab some of the data that I just took and put it on a thumb drive, run it inside, and take a quick look and see, because this thing is tracking so well that I'm going to be able to walk away from this. I'm a little bit afraid to touch it. This guy's a little close to the edge. Man, but I don't want to touch it because it's tracking so well. I'm really happy with that. I'm going to make sure that we're saving the data. Right, this is 86688. Yeah, we are. Okay. Excellent. It's drifting up. So I'm gonna bang on this one little tap down, and that'll scooch those guys down a little bit. I don't know if you can see these two fainter stars over here. There's some cosmic rays over here. It's always cool to see cosmic rays. Let's see how far down that moved. Oh, it doesn't look like it moved down at all. Maybe I need to bop on it one more time. Let's see what this next one shows. See what this next one shows. Okay, I'm going to bop on that one more time. Yeah, for sure. Give it a little bang going down because it's starting to drift up a little bit. Because yeah, I'm still kind of paranoid about these star shapes. I want them to be round, and so what I'm going to do is I'm going to copy a few of these images onto my thumb drive and run them inside and make sure, wow, that thing is still not scooching down, so I gave it another bang there. Obviously I need to keep both of these in the field of view or I'm going to lose them, which is okay. I mean, I can lose one image or two images or a few. The software that I have is good enough to be able to deal with that. But yeah, look at that. It's it's about to go off the top there. I might need to bang on that one more time. Let's see what this next image does. If it doesn't, yeah, dang. Okay, I'm going to scooch that down again. Because now it's getting to be useless. That close to the edge, my software is going to reject that. Yeah, now it's totally off the edge. I'm going to scooch it down one more. Come on. Guys have to behave. Oh, it's still going up. There's a lot of backlash on this scope. I know that. Now I'm sort of in the mode where I need to get that top star back in. Yeah, it's still... So this is the tender loving care part of the program, right? With an automated system, we don't have this. So if something goes wrong, well, too bad. Okay, so now I've scooched those things down. Let's see. Let's see if I scooch them too far down. I'm definitely not knocking automated systems, though. They are fantastic. And